All right. Welcome, everybody, to another episode of the Puget Systems podcast. This episode, very cool stuff on this one. We're getting a little peek behind the curtain of how Puget Systems kind of does business in a way. And so I'm really excited for this because not a lot of companies do this sort of thing where it's not like a lot of marketing and flash and craziness. So this is going to be really cool. I hope everybody watching has some good questions and stuff. I always like to start off with the guests who may not already know who is joining us. We'll go around clockwise, from my perspective at least. We'll start with John. Who are you and what do you do?
I ask myself that every day. I'm Jon Bach. I founded Puget Systems just about 24 years ago now, and have been running as the company president ever since. And I love the Computex is such a good confluence of like vendor relationships and supply chain and manufacturing and like designs. So that's actually a pretty good epicenter of a lot of what I do now is just build those relationships, capabilities in the company.
I know. And Ben?
Cool. Yeah, my name is Ben. I'm the research and development manager here at Puget Systems. So my department is responsible for researching, developing, and integrating new products into our product line. So yeah, a lot of opportunity and overlap at Computex to meet with the vendors, see what new products are coming out, helping just get that face-to-face relationship building and understanding what's happening in the world.
Cool. All right, thanks. I guess we'll just start off, and I feel like there's going to be a little difference in perspective from John and Ben in this question. But so why does Puget Systems go to Computex? We'll start with John.
Yeah, kind of love to hear both answers to that. Yeah, I mean, so we were just talking to the whole company about this actually earlier. And I'll tell you what, I'll start with what we don't go to Computex for. We don't go for the keynotes. We don't go for the presentations because I could just watch that on YouTube. We go for the face-to-face time and the interactive conversations. So it's a lot more of like the lunches and the dinners and tours and just face-to-face time with people. And it's all about getting to know our industry even better because we have this idea of, there's components here in the US, you go buy the stuff and you build computers. But how those products get designed and who they have in mind when they design them, there's oftentimes a little bit of a knowledge gap there. So we love going there, interacting with the really upstream supply chain to help them understand what it is that we're looking for and help us understand some of the challenges in manufacturing or some of the ways that things can break or like, why is it so hard to build a thing that does this? As you talk to them more independently and see the manufacturing, you get a better sense for that. And so Computex is where everyone comes together. There's like 40,000 people or something. And we get the chance to talk directly to the factory operators and the designers there from overseas, whereas normally we have to telephone that through the US sales team. And so it's a chance for like that direct relationship building and that direct knowledge transfer.
I don't know.
Yeah, mostly I'll be echoing a lot of what John just said, but I mean, John's built this company to be very relationship based, not only with our customers, but also our vendors and suppliers. And like what John was saying here, we're on many Zooms and email chains throughout the week, but when you get this in-person meeting rooms and discussions and even seeing like, their exact offices and where they're in and their manufacturing and their like production capabilities and warehouses, it's a whole different just playing field to open up discussions and collaboration opportunities that don't happen over Zoom and email. It's just a different vibe and a feel, especially when they are manufacturing out of Taiwan specifically. That's great. But even if they aren't, even if they're mainland China manufacturers, there's still another level of relationship building that happens at these conferences.
Nice. Yeah. I think that's interesting too, because like, as a bit of a DIY or enthusiast sort of, and having come up through production, there have been times where I've questioned some of the choices that get made back into manufacturing. Like, especially when it comes to chassis, I feel like there's oftentimes where like the designers or whoever it is that's making these decisions don't actually build in these cases, and they're like, and I don't know, it feels like there's a real disconnect between the decision making and the end product, and so it's nice that we are working hard to kind of help bridge that gap.
Well, yeah, and like sometimes it is just like they didn't think about that something, and so like they just need some input. But a lot of times it's just that there's competing interests. It's really interesting learning in like the whole manufacturing world how anytime you look at a product, there's like this pyramid of when you look at like the most expensive, highest performance stuff, it's a tiny amount of sales. And
Mhm.
as you go down to the more entry level stuff, so now we're talking about like a $400 PC. Yeah, there's going to be like a million $400 PCs sold for every one $5,000 PC. And
Okay.
so a lot of these design choices end up being more about like, all right, we got to make this $100,000 tool to bend this piece of metal in a certain way. If they're going to put in that investment, they need to get a volume out. And so a lot of times there's this competing interests for what it is we're looking for versus what mass market volume production is needing. And so we're looking for the places where as much as possible that can overlap, where we can get something that we want and need, but it doesn't come at the cost of something that makes it usable in a mass market.
Yeah. Right. Nice.
Yeah. Although we don't, carry the same volumes of the, large PC manufacturers, we still have a lot of value and just insight and understanding of what a workstation chassis should look like.
Sure.
So that at least opens up the doors to a lot of these conversations because we are respected in the industry and that perspective. So we can at least, say the best way to kind of wire or configure a chassis, depending on if you're going to scale this as a system integrator or not. And it's a unique perspective. So
Yeah, just offhand, and John, you don't have to give any real specific numbers, but what is our unit count in that way? Because like you're talking about, like it has to scale, right? So $100,000, they got to get the volume. What sort of volume do we have that gives us that leverage to have some weight?
I mean, volume wise, it's not huge. It's been a while since I've looked up the numbers, but we're somewhere in like the 3,000 to 5,000 units a year range. I could be way off even, but it's like in that ballpark, right?
Okay.
Which is like enough that like you can get some people's attention. Like it's not no business, but you go and compare it to, a lot of these, like if we're talking about chassis, a lot of these chassis manufacturers, their most of their volume goes through Amazon or Newegg to DIYers, and maybe even some system integrators and stuff buying on Amazon and Newegg as well. But I bet, and I haven't been shown the financials or anything, but I bet if you look at like the sales breakdown, it's like 80% of their volume goes through Amazon and Newegg. And so they got to keep those people happy. And because it's to DIYers, a lot of these I call it like a Swiss Army knife. You have this chassis that you can like reconfigure 15 different ways so that all the different DIYers are happy. But for a system integrator, it just means that 14 of the 15 ways we toss out, we throw a bunch of stuff in the recycle bin, and the configuration that remains really wasn't like purpose built to like do that one thing really well. It was in a sea of a bunch of other configurations. So it's cool when we can go and talk to these manufacturers and say like, I want you to make the product simpler and cheaper and better because we're actually removing options, not making it a bit more complicated.
Yeah, that's cool. I like that. I like that we're in a position to be able to do that. It seems like we just kind of the industry in general just kind of deals with whatever it is that they are given.
Yeah. Make the best of it.
What so ahead of this, since you were talking about it's a lot of meetings and relationship building and things like that, this has to be planned like way ahead of time.
Yeah, so this is now John's third time attending Computex. Is that correct?
Yeah.
And this was my second too. So we had a little bit of understanding about when to prep and how to prep. But we made the decision early this year to officially kind of flip that switch. And yes, there was enough value in us attending that we wanted to go. So we started in January to do our like pre-planning documents essentially and start reaching out to vendors. That happens a little bit later towards the end of Q1 and into Q2 essentially. But yeah, it's a lot of, we kind of divide up and conquer. We call out our like main initiatives on like, what are we hoping to get out of attending Computex, and then kind of divide amongst the team for, okay, who's going to reach out to this person or this rep to schedule, meetings and tours and what do we want to get out of this trip. So it's a lot that goes in, and then we all load up our schedules probably as packed as you can make it be. There's no room for a whole lot of things. We do give ourselves one day of fun there. Nice. through the entire mix, but yeah, our schedules are completely loaded top to bottom.
Yeah, we have to look at like, all right, how long does it take to drive from here to here? How long does it take to take mass trans from here to here? Oh, we can fit in one more thing. We are definitely of the mindset of if you're going to fly halfway across the world, let's not waste any time.
Yeah.
But it's kind of exhausting too. There's a lot that we do. Um, oh, shoot, I lost my train of thought. But we have to watch ourselves from trying to get too controlling because like Ben said, we'll start this process in January and we'll start reaching out to vendors, and a lot of the answers we'll get back is, I don't know what our plan is yet. And a lot
Oh,
of the
wow.
plans from a lot of the vendors ends up kind of coming together the last couple of weeks before Computex. So it is still, even though we start early, it's a pretty big scramble at the end to prepare.
Were you guys able to get everything done you wanted to get done, or did some things have to kind of say no to?
I feel like we did. There were a few things that were questionable at the end, but I feel like we still made them happen.
Yeah, there's probably always more that you can do.
Sure.
If you were to get one of those special Harry Potter time warp things where you can go back and do more visits and whatnot. But yeah, I mean, overall, for like our high level initiatives that we identified and we went out, we were able to execute on all those pretty well, I'd say.
Nice. And so I guess that's a good point. What were those high level initiatives?
Yeah, so we bucketed into kind of the main groups, and there's a bunch of subcategories, but we don't really need to go into those. But really it was to double down on our mobile workstation approach, which we made the decision to go into last year, but make sure that we're reinforcing that side of the relationships and product line. It was to continue to grow our enterprise business relationships. So a lot of our server products, data center level, that's what we were looking into there. We wanted to continue to look at cooling opportunities, and we know components are going to continue to get hotter and hotter. We need a specific strategy there on what we're going to do, and so fortify those relationships. And was there one more? A lot of ones, but those were at least the main ones, and then we had a bunch of kind of sub-tier ones from there too as well.
Nice, right on. Well,
sorry, it's real quick, just the chassis developments, and we already kind of talked about those, but that was also to be able to scale out something that fit us more as a system integrator versus a DIY chassis.
Sure. Yeah.
And we can't put it up on the screen, but like the amount of spreadsheets that are needed to do this is pretty intense. But we find ourselves really thankful for that prep time because, we're working on this months ahead of time. Then you get out to Taiwan and you're like super jet lagged and there's never any time to even think between these meetings. And so that's a great time that like we'll be in the taxi on the way to some meeting and you can just bring up this document that we planned. And we said, all right, we're going to sit down with Gigabyte and our objectives were to figure out XYZ. It's all there. So we don't have to, it's too much to fit in your head, right? So you have to have all this planning per visit.
Neat. Oh man. Yeah, see, and this is why I was excited to have this conversation with you guys, because like a lot of this is very hidden from the public, and there's a lot that goes into building PCs. You guys, like it's not just putting parts in a box. It's really cool. So yeah, okay. So laptops, I want to definitely touch on laptops because we stopped doing laptops. We just got back into laptops, and I guess just to start off, how's that been so far? It's only been a few months. I think we really launched them in April, and here we're in a little bit of July, so it's been a couple months.
Yeah, we announced in Q1, and then we've slowly been selling month after month, increasing volumes over time. Of course, when you re-enter a product line, it's going to take some time to get momentum. But yeah, I mean, our like higher level strategy for this as a whole is we know we're not going to come in and change everything in year one or even year two. It's going to take some time here to like grow and help shape, this segment in mobile workstations where we think we can provide a lot of value, the same, if not better value that we're providing at our desktop level workstations. But it's going to take consistent efforts. It's not just to dip your toe in, sell some units, get out. It's gonna, we're gonna need to understand the product again, understand our customers' needs of the product, and that takes actually doing. And so that's where we started with this year is actually selling, getting feedback, continuing to work with the vendors that we met overseas and Taiwan again, to help develop those relationships and share the feedback from our customers too on where we want these products to shape into.
Yeah.
And so far, so good. I mean, we were very careful. Like we're starting at the top of the stack. So I was talking about that pyramid earlier. We're selling ridiculously high-end laptops with basically the top-end options you can possibly get, which means that it's heavy. It doesn't have a lot of battery life because this is not the same as like the little unit you carry around to check your email. And so we have to be really careful that we position it that way. Like this is a workstation you can carry from one desk to the other desk. It is not a laptop you take to Starbucks and game on or something. And so I think, we probably played it up even more than we needed to, that we wanted to be really careful with our customers so they understood how we were positioning it. And I think props to our consulting team because I think we're doing that job well. And the feedback we're getting from customers, some of it not surprising. There's things we want to improve on, this or that piece. But for the most part, I think it's positioning really well. And that's giving us the confidence to continue. But to Ben's point, like we can't get anything we want here. We know that this is a long ongoing relationship with the factories, and we have to partner with them over many generations in order to steer the industry and the supply chain where we want it. It's not the type of thing where we can say, I need these features, you must do it. I mean, we could do that if we wanted to buy 1 million units, but we have to start small, and we have to know that influence is our approach, not dictation. So yeah, it's going to take a long time, and we have to build relationships with multiple providers to do that.
Are you finding it the folks closer to the beginning, or the closer further up the chain, are they receptive to that? I know a lot of the real high-end stuff tends to be very flashy and a little more enthusiast or gamer centric, and that's not really our vibe. And so I'm curious if they're receptive to that sort of crossover of like power and professional.
Yeah, you're right, Houston. Like really the model that we're targeting is like a gamer laptop essentially, but we're not really using it for gaming. That's not our targeted workflows and use cases. And so in their eyes, they want to be able to sell enough units to essentially justify the cost of tooling and production and everything for that unit. So they want to sell to whatever they're going to get more units from. And right now that is more gamers than it is people doing mobile workstation work with the ODMs that we're working with right now. But we're hopefully going to influence that change there. So that's the goal.
Nice.
Well, there's a spectrum there. There are gaming features that they're not hurting anything, and it doesn't impact the reliability. It doesn't impact the image for professional uses. So there's some things that we can, I guess, quote unquote, tolerate. But then there's other things where okay, that RGB went a little too far, and nobody's going to view this as a respectable product in a professional use. And so we have to it's a compromise. Where in fact, in a lot of ways, the gaming sales is a help to us because it helps drive that volume that allows some more intricate, manufacturing processes. So we don't want to completely separate ourselves from that, but we do need to make sure we're not cutting our own legs off with the features they're trying to bring in. Overall, the challenge in manufacturing, just as a quick lesson into the industry for people, the overall problem is you may look at a lot of high-end laptops and say why is this still using plastic and things like that? And it's because, again, that pyramid. If you're going to do a magnesium alloy type of laptop, you see with a lot of Apple laptops, really great fit and finish, great manufacturing quality. But the tooling costs $1 million to make. And so you have to sell, literally, and you have to sell a lot of units to drive that. Well, now you're at the top of the pyramid trying to make this, $6,000-$8,000 laptop, and worldwide it's going to be 50,000 units being sold or something. It doesn't pay for the tooling to make that happen. And so that's where you got to combine volume, and you got to combine industries in order to make that economically possible. And so that's part of what we're trying to do here is I want to bring that fit and finish manufacturing quality as high end up the stack as we possibly can, where that's economically viable. But that's why there's that problem is it's just a volume problem.
Makes sense. Yeah, that makes sense. So we jumped back into this at the really high end. You're saying near the top of that pyramid. Is there space for us or an interest for us to go lower down that pyramid?
Yeah, I think we're evaluating that. So far, a lot of the feedback that we've collected is our users are also interested in a mid-range laptop offering as well. The problem there is for us to, certify or get behind a product that we believe provides enough value, or that we can standify that's Puget quality. It's kind of the same problem even at the higher end, but we want to be, there's a lot more people doing the mid-range and low-range laptops too. So we're going to even be more specific in what we look at there. So hopefully we find a fit, but yeah, we're looking at it right now because based on initial feedback, it sounds like there's a lot of workstation users also interested in that mid-range tier.
Yeah, okay. And what about ARM? I know they're, especially with Apple starting to make their own chips in that architecture and whatnot. How does that look in just, I suppose, in a broad sense?
Yeah, we're keeping our.
Oh, no, go ahead.
I was going to say we're keeping our ears open for sure because it's very interesting to us, and even I think it's the Snapdragon Elite that's been getting a lot of public attention right now on everything that they're doing with being able to improve battery life and sleep functionality. But it still seems like it's coming in as a first kind of wave product here. So really at Puget, we're probably right now at a wait and see how this develops. We're color us interested for sure to see how this develops over time. But, there's going to take a lot of work on the emulation for applications and even just application support in general, that for our users, if they're trying to get their work done, that's probably not the best, first wave product for them to get into.
Yeah, I think Apple has shown that it can be done because they've switched all over to ARM architecture, but they also have that, ability through a controlled ecosystem to just kind of will that into existence through just hard work. And on the Windows side, first of all, it's probably enough now. There was a bunch of buzz about Copilot PCs, and most of those were on Snapdragon ARM architecture. And if your need is to get into Windows, run some Copilot stuff, and run a web browser, yeah, it's probably good enough for that. And great battery life, great performance. The challenge is that now, all right, run your scientific application on that. And we'll see that shift over time. Photoshop, I bet, is already okay. I know that DaVinci Resolve is working on some designs, and we'll see more and more of those applications. But to get to the point on x86 where it's, who knows, millions of different applications, it all has to be ported over one at a time. So it's not going to happen quick. But you are going to get the more consumer stuff where there's a lot of people. Yeah, that'll move faster. But I don't think our high-end workstations are probably going to be on ARM anytime soon. There may be some ARM options, but it'll be a long time.
Yeah, that makes sense. You brought up, you mentioned Copilot and some AI stuff. I know from some of our previous notes that AI was everywhere, and in particular, I've been hearing a lot of this NPU talk, and it reminds me of the early days when you had a math coprocessor. It seems like a separate little piece that does a little extra work for you, and
it's like your physics engine for gaming.
Sure. Yeah. And can you shed a little bit of light on that and what all that is and what it means? Because even I'm up to my eyeballs in this, and I still don't really get it.
Yeah. Well, we've had to spend a lot of time trying to get it too. But yeah, you're right. There's AI everywhere, and to a ridiculous extent, honestly. What's an AI power supply? But everyone was talking about AI. But I think Qualcomm did a great job. Oh, I wasn't trying to dig anyone in particular. There's everything had AI at the booth.
Yeah.
But Qualcomm did a good job making a really good splash with their laptop designs, and with heavy joint go-to-market strategy with Microsoft with their Copilot. And we've been hearing about it from Intel and AMD. So you're going to start seeing more and more that the concept of an NPU, I guess it's neural processing unit, a little bit of a piece of silicon on your CPU that is specifically designed to run AI inference. And because this is true for any sort of compute, because it is specifically designed to do that one task, it does it exceedingly well at exceedingly lower power. And so the next arms race on CPUs, as long as the AI, remains this hot topic, is going to be this arms race for how powerful these NPUs are. And these NPUs are measured in their tops. I don't even know what that stands for. Is it total operations per second? I don't know. It's
That'd be
something
my guess.
operations per second.
Sure.
But it's how fast can it do this AI stuff? How fast can it do
Yeah.
inference? And on the first generation of product, you have these NPUs that exist, but they're not really all that fast. They could do some stuff, but not. AI was like emerging.
Sure.
And now that Microsoft is getting to the point where they're building in Copilot to the next version of Windows, as it's like it is now a feature of Windows that it will do some of this AI stuff. Now we're getting to the point where there's finally a standard that's emerging for how much power do you need to do this. And I ended up, I don't know if you want to toss it up. I ended up putting a chart together because I can't find all this information in one place. So this is not private information. This is all like I just Googled. But this is just a chart of like how fast are these NPUs going to be over time and how fast do they need to be to run this Microsoft Copilot. So Microsoft says you need 40 tops to run Copilot. Qualcomm, probably no coincidence. That happens to be exactly how many tops Qualcomm has as they launch these AI PCs. But we're just going to continue to see this number go up and to the right every generation with both Intel and AMD, because it'll just give you more capability to run this AI stuff, not on the cloud, on your computer, so that the latency is really low, the responsiveness is fast, it's your data. It helps kind of get us past this version 1.0 of AI, which is everything gets run on the OpenAI API. And now it comes down onto your device. So that was like everywhere at Computex.
Right on. Interesting, nice, perfect segue into servers. So a lot of these early days stuff with OpenAI and all these different LLMs and whatnot. A lot of this cloud, there's all this cloud services. I know that we have seen a massive shift, and I've seen articles and things about it as well, that people aren't really liking having to deal with these cloud services. They're expensive and frankly, the security and things. So we're seeing more on-prem. That leads us into that space as well. So, I guess I'm going to read this one out straight from our notes. As Puget Systems grows into the server market, what are the strategic goals and challenges for us?
Yeah, I mean, I can kick this off. So I think you guys have already had Chris Stevenson on for a podcast earlier too. So yeah, I mean, so he's our enterprise business development manager, and so he was with us too on the trip. And so one of the biggest pieces of his contribution is to help us get engaged with these enterprise partners, a lot of server partners. So I mean, just starting with the challenges here. I mean, one of the biggest things is similar to the laptops and how we're talking about wanting to be able to influence change there. It's another piece too on the enterprise server business, because as it stands currently, we're working on growing our run rate there and re-entering that space too with a heavy presence, but that doesn't happen overnight. It's not something where we can go to, server partners and be like, hey, we're Puget Systems. We've had this awesome workstation business that just translates directly into server. It doesn't work like that. It honestly gives us less clout than I thought it would coming into some of these projects. But that's okay. I mean, a lot of these are specific different business units where, motherboard manufacturer will have just two different divisions where sometimes they don't even talk side by side. So they might not even know who Puget Systems is, even though we're doing a ton of business with them on the workstation side. It's always blown my mind a little bit seeing that. So, I mean, one of our biggest goals there is to help diversify relationships on the enterprise side and see who's willing to grow with us at the point of where we are now in this journey. So that was a big thing. We had a lot of meetings set up to just kind of re-highlight where Puget is at in their journey and kind of how we can, collaborate on our way up this chain.
Yeah.
And tons of partners doing that. I mean, we tie in MyTech, Gigabyte, Azus, ASRock, MSI, Chenbro, lot. Yeah. I mean, it was a lot of meetings.
Wow, it's a lot of meetings. And I imagine, without getting into specifics, we felt pretty good about that.
Well, I think we learned a lot about where all these different partners are focusing and where they want to go. And I can only speak for myself here, but I felt like we were going into Computex was like, we need to pick a partner. And it came out of Computex realizing that was the wrong question. The right question was get to know each of these partners and figure out where we align. And so we'll end up with like, okay, servers that are doing this is a good partner. Servers that have maybe storage servers, we want to partner over here. Play to everyone's strengths and build all those relationships, not, because we don't do that anywhere else. We don't say like, we have one VGA partner.
Right.
No, it's we go where each person has a strength and we keep all those relationships vibrant.
Nice.
But yeah, I mean, it was interesting to see. Man, the Gigabyte booth was nuts. Or not Gigabyte, Giga Computing.
Yeah.
And a lot of these different booths were showing like the big NVIDIA DGX type solutions. That these are hundreds of thousands of dollars, and these are very much built for large scale type operations. And that is where a lot of server and AI stuff specifically is now. And you hear about some of these, AI build outs, these data center deployments. You hear every day about, Meta buys up 10,000 H100s or something, they're just huge amounts of compute. And then we hear through our context, through Intel and whatnot, that we're to the point now where these data centers, we're out of power, we're out of water. I've been hearing talk about like direct attached nuclear power to data centers, and so there's a limit, and that limit is being manifested in cost. And I don't think a lot of people realize that we're at the stage in AI where these companies don't have to make money yet. It's all about racing to be the biggest market share, and then they monetize later. And so it's only going to get more expensive. And as it does, we're going to move to phase 2 of AI, which is closer, on-prem, less in the cloud. There's always going to be a cloud piece. I'm not trying to say cloud goes away. But we're going to see this more and more go back on site for either performance reasons, power reasons, data privacy reasons. And that's the piece that we're trying to position ourselves for. And so it's a little bit of like we're trying to position ourselves to where AI will be in 2 years, not where everything is now. And so it's like Ben said, it's finding those partners that have a similar mindset. So 2 years from now, I want to be selling in a rack of computers to a lot of mid-sized and large businesses because they're realizing that they need to have some of their stuff in the cloud, some of it on-prem, some of it on Copilot on each person's workstation. It's going to be pieces of the workload happening everywhere. And that's why we are getting involved almost everywhere. Because there's going to be a performance need and a need for us to do our testing and like optimization at each of those junctions.
Yeah, a little bit more on like the business operations side. On the workstation side, the more that we can kind of confine our configurations to like limited, motherboard partners or different configurations of what those builds are, the easier it is to, hit economies of scale for everything from, compliance certifications to just productivity and efficiency and production getting out the door. But the enterprise side and servers, it's a different ballgame altogether. And that allows us, pretty much we're able to be a lot more flexible with many partners there, because a lot of these servers are very specific configurations that are niche and unique to what the customer is doing, even more so than workstation. So it allows just additional flexibility for us, for who we're working with and what products we're bringing in, essentially. We have a saying that goes around the office a lot now that servers are a snowflake. There's no, unique one that we use quite a bit because a lot of the deployments that we've done so far just have been pretty unique. Each case has been different, where we're relying on different partners to make it come through.
Cool. Oh, that's always exciting. As a bit of an aside, I've kind of missed seeing some of the things that we are helping to other people to accomplish and stuff. I miss a little bit of that from being in production. Let me see here. We got a question from YouTube. In the vein of moving away from big cloud, TM, does Puget Systems have anything target the home labbers a la 45 drives HL15? From Stephen Reeves.
Yeah, I'm not familiar with HL15, but Ben, we have directly positioned storage servers, right?
Mm-hmm. Yeah, we have software-defined storage solutions too on our page, as well as kind of unique offerings there. And we've come back, I guess, to more custom computing options. We still are a custom computing manufacturer, but especially on the server side, if you're looking at something that doesn't see or fit your needs there on our product page, talk to us, because we have a lot of options on what we can do.
And with those servers, I mean, you do need to have capabilities on, you want to hold a slide, drive sleds and whatnot. But a lot of the magic happens on the software side. And it's been great to we partner with a company called OS Nexus up out of Redmond here. And it's great because they're local. We get to know them really well. But it allows us to do the file, block, and object storage, a lot of tuning and configuration. And, the whole deployment has to be done right. So this is a little bit different than on workstations where it's, here's your workstation, go set it up. This is more, we're going to have like a pre-call. We're going to gather requirements about like your specific setup. And then OS Nexus does a great job on delivery of the servers as well. They go through like a whole deployment process. Because if you don't set it up right, it's not going to do the right thing. So that might be a little bit more than like a home labber would be interested in. But frankly, a home labber would probably benefit from. But this is more targeted to mid-sized businesses that like there's an infrastructure and a known workload that they have a performance requirement to hit.
That's cool. That it's the full solution, like top to bottom. That's very cool. Yeah. I guess we'll move on to cooling, because I think that's a big one for everybody. This is going to affect everybody from the DIYer all the way up to, like you were saying, people are talking about having small nuclear plants near their data centers. Like that's mind-boggling to me. But also, like,
next cooler is a nuclear power plant cooler.
Right. So, I guess, I mean, I know from our notes here that a big question is everything's getting hotter. So what should we do about that? And so what are we doing about that?
I think the first thing is to learn. We have the privilege of getting to know the founder owner of Noctua. Roland is his name, and he's the kind of guy that's just infectious to be around because you can tell he's a total geek when it comes to cooling, and that means that every time you talk to him, he starts talking from passion, and you can't help but get enthusiastic also. So anyway, one of the things we asked him was, all right, when GPUs are getting everything's getting ridiculous, everything's getting hotter, it's getting a higher power. And so we kind of phrased the question to him of like, how soon until you go liquid cooling? And it was great to hear kind of input back from him on like, no. We have things that we can still do. There's still mountains to climb here on the air cooling side. And there's things that we've seen on GPUs that we haven't yet seen on CPUs, like vapor chambers. Noctua was showing off at their booth, thermal siphon, which is essentially it looks like an all-in-one liquid cooler, but it's actually, I keep saying that it's like, just think of it like flexible heat pipes or like unidirectional flexible heat pipes. And so there's no pump, it should be just as reliable as an air cooler. But you have the benefit of, you can stick your radiator somewhere else so that the heat can get out of the chassis. And that's the thing that like I was rubbing my hands earlier, because I've earned a reputation here at Puget for getting maybe too excited about this. I just think that there's an opportunity where we've watched now for the last 5-6 years this dynamic emerge where honestly, like the ATX form factor of computers was broken 5 years ago. And yet it's an ecosystem that we're all locked into because everyone has to decide to change at the exact same time to get to anything else. And that's never going to happen. So you end up with like these GPUs that are just blowing hot air into the chassis. You have CPU coolers that are blowing hot air into the chassis. And then as system integrators, one of our jobs is get that hot air out of here. I would much rather design a solution that just doesn't have the hot air in there. And so I want the hot air out. When you have a company like Noctua or any cooler manufacturer have to make a product that can go into anything. Again, we're talking about a problem of volume again. They have to build a product that they can sell 1 million of. And the way that they do that is it has to work in any chassis on any motherboard. But we don't have that need at Puget Systems. We have our 3 chassis and our 5 motherboards. And so we do have the capability, and this is what we're developing, is to work more and more with chassis providers to make a custom chassis, cooler providers to make a custom cooler. And we can actually then design it from the ground up. So instead of taking custom or off-the-shelf components and assembling them intelligently and testing them, which is great, we can now actually, let's have a hand in designing those components so that the system as it comes together is the best it possibly can be. And it was cool to sit down with Roland, sit down with Noctua, and have those kind of conversations, because when you geek out over how good can cooling possibly be, you want to do that. So it's just a great chance for us to partner up with Noctua. We have plans to participate in this thermosiphon as it comes to market. But even if it doesn't, I want to work with them to like answer that question of how good can cooling possibly be if you remove these constraints of it has to work for everything. So that's where we're going. That's where we tour these factories. And I've talked for 5 minutes now, so you can tell I'm passionate about it.
No, that's really exciting stuff. I know earlier. Well, this was a handful of years ago now that we were working on a custom chassis. Some folks, you might see it in some of our marketing material and things like that. Some background photos and things that we have. I think really the pandemic kind of put the kibosh on that, so to speak. So it's really exciting to hear that we're building those relationships to kind of really move faster in that direction and to connect all of these disparate parts together to make like, oh man, it's exciting to think about like not just a custom Puget Systems chassis, but a whole solution. Again, it keeps popping up, these full stack solutions on solving these problems. It's very cool.
Absolutely.
Right. Yeah. We did have a question from LinkedIn from Ashley Listmeister. She asked, what was your favorite food that you had on the trip? Specifically, she said, John, I'm curious about the both of you.
Okay. We probably give the same answer. We had the pleasure of going to dinner with Faison on one of the last days of the trip. And I don't know, there's probably this kind of thing in the US that I'm not cultured enough to go to. But they set out these like little barbecue stations, like charcoal or something going inside. And then this really nice cube steak that on your table. So it's almost like a melting pot type of experience where you cook your own food. So we ended up kind of grilling our own steaks right there on these grills, and it was fantastic. It was really good.
Yeah, there was we did a lot of family style meals for most of our lunches and dinners. It felt like a good amount of like teppanyaki style too, which is fun. Probably the steak stood out for sure, because it was that was an experience altogether. But yeah, it's always, I mean, the food, the culture over there, it's always impressive. We could make a whole trip out of just trying new food and experiences there for sure.
Yeah. Oh man, for me, that's one of the biggest reasons to travel is for the food. I'm a big fan of that. Oh, John's got a picture here. Can we share this?
I don't know if I can put it up. Oh yeah.
Yeah. Okay. We'll share it.
Got to get a picture of Ben here doing the steak. Yeah. That was good stuff.
All right, on. That's cool. Earlier you'd mentioned about getting to see tours and stuff. Without, I always try and be cagey about specifics and things when we're talking about these sorts of in-depth things like this. What sort of some of the general takeaways that you guys found when you're, because I know you got to see really how it's done, how the sausage is really made in a real way.
Yeah, so I know John and I have both seen a handful of SMT lines before, and so I don't think anything.
What is SMT?
I actually don't know what it stands for. Is it?
What does it stand for?
That's okay.
I can
something manufacturing technique, maybe. I don't know.
Yeah, maybe. I probably should know that.
It's okay.
And most of those lines have been for like drive production, RAM production, those type of components. But it was our first time seeing motherboard manufacturing and that whole process that goes into it. So I know that was very eye-opening for us on a lot of levels, but especially I think what we're trying to bring back into our company now is seeing, at least with the factory that we toured, on how many just human interaction elements are still involved in the process. And the capability for errors. They definitely have a lot of quality control processes and things built in, but there's still opportunities, and some of them is likely what we could be recognizing and identifying during our production process here and support issues in the field. I think there's some trace back loops that we can essentially look back and see if there's any signs of things that happen during the factory manufacturing process that we could point back to and even give feedback back to these motherboard vendors and factories.
Yeah. Well, I mean, just to define SMT real quick. So that's like you have this PCB and you have all these components, all these little capacitors and transistors and stuff. And you have a machine that just takes it and puts it onto the board.
Hmm.
And then there's like a soldering process that happens. It might be a, what do they call it? A wave solder. But then it goes through an oven and it, heats it up to the right temperature. But it's this process of like picking all those components and sticking them onto the PCB. But yeah, I'm just going to say it again because it's worth emphasizing that there's a lot of automation that goes into this process now, but there is still a shocking amount of steps, particularly as you go from one automated process to the next automated process, that is still a very manual step. And as we're touring these facilities, we're like, oh, I can see how you could make a mistake. And like you put this product under the wrong line, or you load the wrong tape machine into the batch, and now they're all getting the wrong, NAND capacity. There's like a labeling step that's in a different room for the manufacturing step. Well, what if you label it with the wrong thing? So I think even as like humankind, we tend to have a challenge where as we add more automation, we get comfortable and feel like there's not an opportunity for error. And that's where the really bad errors can end up happening. And we saw that it's not a dig on any particular company here. We saw it across multiple tours that there's still a lot of manual steps. And it's really important for us to understand those steps, because it helps us know what to look for.
Sure.
There's one step, I'm eager to share this in with our support team. There's one step where we were watching at a factory, motherboards coming off of a soldering line. And then there was a human step of checking all the solder points and touching them up. You want to know how many touch-ups they do? A lot. A lot. And so one thing we could take from that is, all right, if we have a bad solder point on the bottom of RAM stick number 4, we can learn to do that. Let's just touch it up. But at the very least, it gives us an opportunity to look for, why did this thing fail? Where are the biggest opportunities for failure? Where should we inject more process and our quality control? Because we know there's a little bit of a blind spot at the factory in a particular step.
Oh, interesting. Yeah. Frankly, just knowing some of that process can help take some of the frustration away. Because like you can be a little bit more empathetic when you know that, like, oh, yeah, okay, yeah, they're not just being sloppy. This just happens sometimes, and
Yeah. I mean, you go to these factories and we don't have the work ethic in the US to do what they do. I'll just say it like that. It's not a matter of they don't care, or you get a lot of appreciation when you go to these factories to just how complex the manufacturing process is, and how many opportunities. It's actually amazing how little goes wrong given how much could go wrong when you look at how this stuff is made. So yeah, I think there should be a lot more empathy in why they're the failures that we have. But yeah, it's you learn a lot. You probably learn a lot about empathy than you do about knowledge of technology during these factories.
Oh, we have a definition here for SMT. Somebody, Craig Dunwood, he put it here in the YouTube. Just the word of it is surface mount technology. So thank you, Craig.
Okay. Put the thing on the surface.
Yeah.
Yes.
And then we had an interesting comment from Richard F. on YouTube as well. He says, I saw Linus put out a video saying the new ARM chips from Snapdragon only had a 26 to 40% real world hit on x86 emulation. Curious when that emulation will become so small it no longer matters, or when the general performance of the ARM chips for desktop future outdo x86 with emulation. Any vague comments, perhaps? Some future crystal ball?
Yeah, I mean, that'll be tough. I know we're working on getting some ARM units in-house to do some testing and just see really what the emulation experience is like. But yeah, I imagine, it'll take iterative improvements, generation after generation. It's not going to be a home run swing or anything. I'm not comfortable or knowledgeable enough to give numbers for years or timeline at this point, but I'd imagine it'll take a couple iterations to get there.
Sure.
Yeah, I can't speak for everyone, but like one of my impressions of ARM. So you had Apple starting to use, the M1, M2, M3 chips, and the performance gains that they're able to achieve in specific workloads. Now, keep in mind, they're like They're doing the same game as anyone else where they're cherry picking the numbers that look best. But nevertheless, if you look at like how long it takes to render a video, if you have silicon that was designed with that in mind, it is going to perform amazingly. But that's not something that's magical to ARM. A lot of what ARM has going for it is that it's an open ecosystem. It doesn't have a lot of the baggage of it's been around for 80 years, or not that long. It's been around for a long time. And so there's a lot that's depending on it. And so they can be more bold with those type design choices. But there's nothing stopping x86 or Intel and AMD, I guess, in specific, to be innovative as well. And so it kind of depends on who you listen to. Like if you're listening to Intel today, they would say, sure, ARM came out with a great product. Just wait till our next gen. We're capable of those same types of things. And, yeah, you can have whatever reaction to that. But I think that ARM is a kick in the rear to the existing industry. And so you will see it become more innovative. So Richard, hi Richard, by the way. I don't think that we are necessarily locked into like emulation is the only way that these things are going to work. I think you're going to see Intel and AMD come back with a pretty good answer. But you're right. I mean, we're not seeing, nobody's talking these days around, what's the virtualization performance hit of VMware for server workloads. It's just become kind of an accepted overhead. And yeah, that could very much be what happens on ARM as well.
I wonder too if we'll see a shift in software development. Because it doesn't make sense to just continue emulating. I know it's going to have to be a sort of a stopgap if the industry has a major shift toward an ARM architecture, you're going to have to change how you do your software development. I guess it's one or the other in a sense. Like, okay, is ARM going to take over, or is there going to be some sort of mix that we see here?
It's the same problem as in manufacturing that. All right, you got these devs. They don't have infinite time. They're going to develop for wherever the most people are.
Yeah.
And that's a huge advantage that Apple has in this kind of locked ecosystem is they have a captured user base that they can put development time into. And yeah, on x86 versus ARM, it's really going to come down to adoption more than anything.
Yeah. It'll be interesting to see how it goes because I mean, everybody has some experience with ARM with all of your mobile devices, tablets and cell phones and all these other bits and bobs that run this stuff. So yeah, it'll be interesting to see how things change over time. Let's see. I guess we kind of hit all the bullet points and stuff in our notes. Is there anything else you guys want to mention or talk about?
Maybe quickly on the factory, because I know, or the factory tours. So the same factory too with the motherboard manufacturing. I also took away just that factory has been around for 20 plus years. But so they had some older style like inventory picker type automation that was just fascinating to find out that that's been around for 20 years. But just giant warehouse space with robotic arms that's programmed to pull exactly what components that it needs. And just knowing that that's been around for 20 years now is really cool. And then they also had some like new style robotics and automation for like carrying around or just like little robots on the floor, blanking out, Roombas. They're like Roomba type devices that would just move around the factory floor and bring materials when the bin was out to the individual stations that were working. And so I honestly just like screamed out the efficiency. Like they had it figured out with the human aspect as well as like the coupling automation. And I guarantee they're going to continue to pull more and more automation over time. But even just what they had figured out so far with the different inventory binning and then like pulling in supplies as they needed was really fascinating and cool to see.
Yeah, it was a cool like juxtaposition of like this is a factory that's been around for a while. It wasn't super old. It was like, what was it, in the 90s or something? When was that built?
2000s, like early 2000s, I want to say.
Okay. And so, yeah, I mean, there's a fair amount of CRT monitors around in some places. But it's not like they built it and the innovation stops. They're like constantly iterating. There was another point through one of the assembly lines where on one side of the assembly line, there were humans doing their job. And on the other side, they had set up this like pod for this robotic arm to do its thing. And the robotic arm wasn't working at the moment. They were like, it was broken. They were either that or they're working to implement it. But the point is it wasn't an all or nothing. It was like they added to the mix automation and didn't rely on it at first until it proved itself out. And then, all right, sure, humans can be removed from that particular step of 25 steps. So it's a very iterative, one little thing at a time. But it was cool to see that a factory that is fairly old was still, there's every day something is happening to try to push the ball forward there.
Neat. That's cool. That's cool to hear, and especially with all the doom and gloom of AI is going to take my jobs and stuff, and it's kind of good to hear that there's still a human element that still is going to be required no matter what.
There's cool. A lot of people are going to be needed to make sure these robots do the right thing.
Sure.
Stay in school, kids, learn all this stuff, because we're going to need a lot of help with this automation. And frankly, it's going to be a lot more interesting of a job than sitting on an SMT line checking solder points for 8 hours a day.
Yeah. Learn Python, kids. Right? Or C+. I think C++ and Python are the big ones. Yeah. Well, I mean, I'm okay if we wrap this up a little early, you guys. If I feel like we really gave everybody a really good, interesting view on how computers do their thing.
Yeah, I feel like we could pull out some more topics, but they're probably not 5-minute topics.
Sure.
Especially if they're cooling related, they'd be another hour with John.
But it's going to be the most fascinating thing. I really am really excited to see how that progresses. Not just the cooling part, but getting all of those pieces together. I'm especially just from our company angle, because I think, frankly, that's something that nobody outside of maybe a few like really high end enterprise level stuff, nobody like us is doing something like that, and that is going to be super freaking cool. I think that's just one more thing that's going to set us apart from anybody else who's doing this kind of thing.
Yeah, well, I'll just echo like what you said earlier, Houston, of like being a system builder isn't just Legoing computers together. There's a interactive participation with the whole industry that has to happen. And that's the big piece of what we want Puget Systems to be. And to be that kind of voice for the users back into the industry, because the industry, absent of that like direction or feedback, will just end up racing to the bottom. It'll race into wherever the most volume is, wherever the most profit is, most margin is. And so you'll end up with whole sets of users getting ignored in that process. So that's our job. And so, we do feel like when we go to Computex, we're like ambassadors where we're trying to influence a system that might be too big for us to, get much egos about us and think that we can get anything we want, but we want to show up. We want to have a voice. And we know that like we're just going to have these little wins. And we're going to steer this ship to where we think is a better place. So yeah, I was talking to the company earlier of like how many years are we just going to keep going? As long as we come back with these kinds of stories and learnings and wins, we'll keep going.
Yeah, I think in all of these initiatives, it's like consistency is going to be clear here and communicating the feedback. Because if it's a one-time feedback loop or whatever, that's not gonna give us nearly like the information back and forth and exchange and relationship rapport that it takes. So we're in for the long haul on a lot of these new initiatives too for Puget, but we're dedicated.
Yeah, and I know we're going to do a great job because we have the experience. We've made some interesting we've been the catalyst for some interesting changes in other aspects of this industry. I don't think I could say anything specific, right? I always try and be cagey, but I know that our feedback, our influence has made a big difference to the industry as a whole. Like whether it's whatever parts and stuff, it really does make a difference, and it's really interesting. It's really interesting to see how unique that is. Actually, that like it feels like we're the only ones doing it, and that seems really strange, but also very exciting and cool because that means we're unique and we're actually helping and making changes and solving problems, and that's always really cool.
It's more fulfilling too.
Yeah. It's always it's neat to be able to point and say, "Oh, I did that," and look what the benefit for everybody. I don't know. It's very cool. I like it. So I guess with on that, I think we'll wrap it up. We brought us about to our hour here, so I want to thanks John and Ben for taking time out of the day, and thanks to the audience as well for joining us and asking some great questions and things and keeping the conversation going. So thank you.
See you later.
Thank you. Thanks. Thanks all.
We do this, we're planning on doing this every first Tuesday of every month. I'm not sure what next month's going to be quite yet, but stay tuned for that. First Tuesday of every month, we're going to do the Puget Systems podcast like this. So mark your calendars. Right now, we're doing YouTube, Twitch, and LinkedIn. Where we're going to expand to other platforms as well. So keep an eye out. Thanks, everybody. We'll see you next time. Bye.
Thanks, Houston. See ya.